Okay, so hello everybody, a very good evening and welcome to Albuquerque IEEE Women in Engineering Affinity Group Public Talk Series. So I'm Aisha, I'm the chair of Albuquerque IEEE Women in Engineering Affinity Group. And with us, we also have our vice chair, Sadman Siraj, and our advisor, Dr. Siropolo. Before we start today's talk, we would like to thank Dr. Kyrarini so much for bringing out some time for us to join us as our key speaker. So Dr. Kyrarini is an assistant professor in the ECE department in Santa Clara University. She also serves as the assistant director in Heracli Human-Centered Computing Lab. Her research field of interest includes human-robot interaction, robot learning from human demonstrations, assistive robotics, etc. So luckily, she is also going to talk about assistive robotics for people with impairments today, and hoping that it will be a very, very interesting talk. Today's talk will be a 45 minutes talk with 15 minutes question and answer session at the end of the talk. And before we start our talk, I believe Dr. Siropolo could say something about our affinity group here.
Yeah, so thank you very much, Aisa, and I would like to thank also our speaker, Maria, for kindly accepting the invitation to give this talk. I'm pretty sure that it will be amazing and very informative. Before we start the talk, I want to give a little bit of background about the amazing academic background that Maria has. And given that we share the same alma mater, the National Technical University of Athens, and actually we entered the Department of Electrical and Computer Engineering the same year. So I know her for several years, and I'm really happy to be with us today. I want to tell you that National Technical University of Athens, it's almost like, I don't know what you want to call it, like the MIT of the US, the Princeton, the Stanford. So it's really the Ivy League school, engineering school in Greece. The entrance into the university is quite tough. As we go through a national exam, and you really have here the elite of researchers from Greece to present. And without taking more time from Maria, the floor is yours.
Thank you very much for the great introduction, and thank you for inviting me. So today I will talk about assistive robots for people with impairments. But before I start talking about it, I think it's a good idea that I kind of like introduce a bit myself. So I mean, you can read most of the things that I have done, but most of the time I like to start with a map. So I was born and raised in Athens, Greece, and I did my undergraduate degree in electrical computer engineering. And after that, I think the time that I graduated was the time that Greece was on crisis. So I was like, okay, what should I do? I already have a job, but I want to do something more. So then I decided that I would do a master's program, which was about automation and systems. So the first year were basically courses, but the second year I decided to apply for an exchange program and go to do my master's thesis in Bremen, Germany. And I have to say that I had no plans for doing a PhD. But after I did my master's thesis, my advisor was saying like, you know, you should really do a PhD. And I was like, I'm not sure if I really want to work on, you know, one problem for like 4 or 5 years. And he was like, no, you should definitely do it. And then I was like, well, okay, I can try. You know, if I don't manage, I can always like, you know, move to industry. But apparently, I really loved my PhD. I think the 4 years I did for my PhD were the best 4 years of my life. And after that, while I was actually completing my PhD, I got an offer to go for a postdoc at UT Arlington in Texas. I didn't really think much. I was like, well, postdoc, I got already the offer, let's go there. You know, and the plan was I will stay for 2 years, but then I really didn't know what I should do next. And my professor was like, you know, you should try to teach one of the courses that we have. When I started teaching as an instructor, not as a TA, which is really different, I realized that I really like it. I really like to put, the materials together. I really like transferring my knowledge to students. And then I was like, well, maybe I should actually apply for assistant professor position. And basically, that's how I landed at Santa Clara University. So if you were asking me back when I was, entering the electrical and computer engineering department, that one day I would be a professor, I would say, you are joking, I will never be a professor in my life. But here I am. So this is, I think, a nice example that you should never say never, because you really don't know what will happen in the future. And with this part, I would like now to switch the talk a bit to basically what we will be talking today, which is more about research. So I will be presenting two of the projects that I was working on during my PhD, which was how we could enable people with motor impairments to interact with robots. Also, I would like to introduce some of the research we are doing here at Santa Clara University, and also what are still the open challenges in the field. So I would like to define a bit what is basically quadriplegia. So this is, or tetraplegia, this is actually a form of paralysis where we have all four limbs and torso not able to move. And that can happen from like several different reasons. Also would like to mention what is the term paralysis, which is basically the loss of the ability to move some or all parts of your body. And a lot of times this is something that could be also temporary. It doesn't have to be permanent, but it can be also permanent. So what we would like to see is how robots have the potential to assist people with impairments. And it could be that the way we interact with the robots is manual, which means that we actually control directly the robot. It could be fully autonomous, which means that the robot does whatever it wants to do and you don't really give any interactions. You just say, hey, I want you to do this task, and then the robot will take care of it. Or you can have something in between. So the something in between is the semi-autonomous approach, which means that you would actually provide instructions along the way, but the robot can do things on its own. And I think that's actually the hard part, to get the sweet spot in between. So I will show first one approach that it's a kind of a combination of how we go from the manual to a fully autonomous approach. So in this case, what we actually would like to do is we would like to learn from people with tetraplegia. So here we had an interface, which was basically hands-free interface. There is a camera that actually points towards the body. And basically by moving the head around, we can actually control the robot. And we can control the end effector, as we say, which is basically the last part of the robotic arm. So we can actually say to it, for example, move forward, backward, right, left, up, down. And we can do that just hands-free, just with head motions. So, and what would actually would mean for a robot to learn? So let's say this example that, we would like for the robot to learn how to move some pins in this example. So we have someone that controls the robot. In this case, it's a joystick, which is kind of like much easier, and demonstrates what the robot's supposed to learn. And then the robot takes some time to learn. Then we can change the location of the objects in the scene, and then we can see how actually the robot learned the task and actually reproduce it, even when the objects are in different locations than where it's supposed to be. And this is quite easy when we have to do with joysticks, but the question is, how do we do that for people that they cannot move from neck down? So we actually use a learning framework which is basically how we can learn from human demonstrations. And this is a complicated version, but I will actually put it down to what we actually need. So the first part is the control of how we can actually match the head gesture movements to whatever the robot's supposed to do. And this is a very complicated part because the robot can move in X, Y, and Z direction, but also it can actually turn, so roll, pitch, yaw. So we had to actually build what is called a state machine that we would be able, with the gestures, to navigate through the different control modes. So, for example, by doing up gesture 2 times, that means that the robot could move in the Z direction, which is basically up and down. And then based on how much we would steer our head, it would go either up, down, and also how fast. Then the next part is that, you know, we collect the data. Then we need to actually learn the robot, understand what the person just saw. And then actually the robot has to reproduce the task. So here is one video that you can see. My colleague, who is tetraplegic, how she was able to control the robot with the head motion in order to grasp the cup. And it was important to keep the head motion, not to use any other method, because that was also her kind of like rehabilitation exercises to keep her mobility, because she has multiple sclerosis. So in order for her to maintain the head motion, she really needed to actually practice. And that was one way for her, like, okay, she had to interact with the robot, but at the same time, she was doing the exercises needed. And as you can see, this is actually, I have speeded it up, but it still takes quite some time. Until the demonstration is done, and then the robot can actually just do the task now. And she was really happy about it because, you know, it was the first time she was actually programming a robot. So we did a study with 12 participants and one with tetraplegia. Everyone was able to successfully do the demonstration with the first attempt. The problem was that the time that needed to do the demonstration was quite high, like 12 minutes to teach the robot of how to bring a cup. Obviously, it's like very long. And that's because we had the state machine and we needed multiple gestures to do. However, we got very positive feedback, and the user with the tetraplegia mentioned that actually it was important for her to do the demonstrations, not someone else, because she felt she was in control. And this is something sometimes we need to think when we are designing systems. And of course, some of the negative things were the time that was taking, and also when we had to do tasks with actual physical contact would be very hard to actually do it. Then we decided to move forward to an approach that's basically semi-autonomous. So we were thinking, okay, a lot of times what we design is, robots to do is grasp a cup, bring it close to the person, and there is a straw that they can drink. But we were talking about having a different approach that actually the person can control the drinking process. So we wanted something that it's actually intuitive, easy to use, safe, and could actually enable drinking without a straw. So we came up with this design of a cup that has basically 2 force sensors and a Bluetooth module so we could get the data. And then we decided to use a vision-based approach to actually find where the person sits and where the head is, and then move the cup towards the person's lips. And then with the force sensors, we would be able to actually do the drinking process. And of course, we wanted to make sure that, you know, when someone is looking somewhere else, the robot is not trying to find this person, like, you know, and give the drink. So what we decided was like, okay, when the person is oriented towards the robot, then we can like start approaching. So in order to do that, the first part that we had to do is actually the face detection and tracking. So we start by detecting the face, and then we needed to estimate where the head is with respect to the robot, and then where the mouth was. And once we did that, basically we had a task control, as we call it, module that would make sure the robot actually goes there. So this is an example of how the vision system would recognize the person's head and also where the mouth is. And once we reach the mouth, we had to actually develop a different controller, which was basically a force control based on what the force was. Like if, for example, the force was applied in the front sensor, the cap would be lifted. If it was the force was applied to the back sensor, the cap would go lower. And then we had some like triggers. If we apply too much pressure, then the robot would actually drive away, because we would consider that as unsafe. So here is one example of how the system worked. So the first part is basically the control, the vision-based approach. So the robot was supposed to find the person and come driving there. And when the person was looking away, then the robot was supposed to stop and after some time, like retreat. So you can see that this was kind of like a game after some time, in order to test that it really like stops. And then when we reach the person, then we start with the force control. So you can see that it takes some time until the user gets familiar with how much force they need to apply. But after some time, it actually, you can learn the thresholds. So we did two studies, one for serving the cap and the second about the force control. So for the first study, we had 25 participants, and most of them were quite actually happy with the system. And we had the second approach, which was basically the drinking process, which again, it felt like it's actually easy and intuitive to use. We had some like wishes from the user. So for example, that the robot could move faster when it was a bit further away. And also, they didn't like really the cap that had the two sensors and the beak. So we decided that we should go with a normal cap. So then we had another setup that we only had one cap to try to do the drinking process, which was much harder because now you had only one input to actually be able to lift the cap up, down, and move it away. And also some of the wishes where they would like to have a user control emergency stop, because right now they really rely on someone else to stop the robot if something goes wrong. The next part I would like now to a bit switch the presentation into patient care, and this is one of the projects that we are working here at Santa Clara University, is about how robots could help actually nurses, because we saw also with the COVID-19 pandemic, nurses are really overwhelmed with all the tasks they're supposed to do every day. So we set up a robot, which is basically a mobile base with a robotic arm, and it's equipped with laser scanner and cameras, and basically can do several tasks. For example, one of them could be go and fetch objects. So we could use, for example, barcodes to recognize the objects in the scene, and then we can go and grasp them. So this is one of the tasks that we are thinking that could help nurses. A second task that we are thinking that we could help nurses is that sometimes nurses need to walk with patients that they just had, for example, surgery or a stroke or heart disease, but it's actually important to take few steps afterwards. So we were that, we could have actually the same robot that could actually fetch objects, also try to help them safely navigate through a hospital environment. So we are actually utilizing reinforcement learning to build this control structure of how a mobile base together with a human could actually navigate crowded environments in hospitals. So we set up basically a simulation environment that actually had a mobile base. There was a person that would be the patient, and then we had humans that they would walk around, and then we had also static obstacles that the robot had to avoid. So basically, you can see in the video that the robot and the patient start walking together, and they want to reach somewhere behind the sofa. So the robot takes some actions of like helping the person steer away of like other humans that they are walking or the obstacles, but actually help the person reach the goal. So after that, and seeing all these interactions between, robots and humans, a lot of times we actually take out the psychological impact the robots may have to people. Because a lot of times we actually think, okay, we would like to help people with this specific task, but we really do not take into account, do they like it? Do they feel stressed when they are using, when they have to interact with robots? So a lot of times I think roboticists focus more on the robot part, but we do need to actually take into account the human aspects as well. So we're thinking about setting up a human-robot collaborative scenario that would actually assist cognitive load assessment. So, and for that, we actually set up a multisensory system that has a ECG, which basically shows us what is happening with the heart, and also EDA, which is basically the response of your skin. So, for example, if you're sweating, you are generating some measurements that we could actually record. And we're thinking by using these two sensors that we would like to investigate if we could actually recognize when a person is getting overwhelmed by the task they have to do together with a robot. So we set up a simple assembly scenario where the robot had to do some tasks and then the human had to do some tasks. And basically that was quite straightforward setup. So the robot would fetch some of the objects, and then the human will have to do some of the hard parts, like putting the parts together and use, for example, a screwdriver that the robot cannot use, and putting a product together. So we basically had a framework that we were able to extract features from the data we collected, and then we were able to recognize if the person is actually has cognitive load that is high or low. So we had a pilot study of 25 participants, and 6 of them did have prior experience with human-robot collaboration. And then we set up the experimental procedure as the first session would be a low cognitive load. So we just say to the person, okay, you can sit and you can do the assembly task, and you can take as much time as you like. There are no restrictions. So then in the second session, they had to actually do the same task with time constraints that they were very harsh. Like most of the times you weren't able to complete the task within 30 seconds. And we wanted to see if actually we could really induce stress and high cognitive load. So we actually find out when we ask with subjective feedback that when they had to actually do the second session, which was basically the one with the time, it was much more stressful. They felt less sleepy, but the attention level didn't really change. And then when we looked at the data, we were actually able to detect that the people were basically had different response when they had to do actually the high cognitive task. And we were able to detect that with 92% of accuracy. So by doing that, we realized that, okay, this is actually very interesting because it would be important to investigate how people with special abilities would be actually able to interact with a robot and if they get stressed. And we were lucky enough that we got an NSF grant that we're supposed to start actually October 1 to investigate this exact problem. Also, when we were looking at the data, we realized that by also reducing the components, we could also get similar results, which is actually quite helpful because this means we can run things faster if we need less data. So the open challenges that we still have, I think number one is safety, because a lot of times we cannot have just a robot with a person, for example, with tetraplegia work on their own. Always someone has to be there to ensure that the robot is safe and nothing will happen. The second part that's really important is personalization. So a lot of times we would like to actually have the system personalized to our needs, and that's really important. The next part is generalization. So we do like to be personalized, but a lot of times we think like, okay, if I teach the robot to do one task, can it actually learn on its own how to do another task? How can it take the knowledge for, for example, we all know how to move a cup around, right? If I change the cup to a bottle, the robot should still be able to do the same task, but for the robot, this is not straightforward. And then the last and most important part is the acceptance by the users. Will the users accept robots as one device that could help them and assist them? So I would like now to conclude my talk, and I gave you a few examples of how we can actually interact with robots. And I also mentioned some of the recent work we are doing about how robots could help with in hospital environments and nurses. And I would like to also acknowledge all of the projects I mentioned, the funding that we have received. And I would like to thank you for your attention. Thank you.
Thank you so much, Dr. Kyrarini, for your valuable speech. So I would like to ask if anyone from the audience have any question regarding today's talk. You can unmute yourself and ask the question.
Yeah, and guys, this is a more friendly, I will say, environment. It's not like pure academic, so you can ask questions that are related or open a discussion that is related to the technical stuff that Maria described. But also, I mean, she has quite the trip around the world, until she settles in California. So questions, more general regarding, women in STEM and difficulties and or not only difficulties, but also challenges, I should say, are more than welcome and as an open discussion.
Maybe I should ask the first question.
Yeah, always somebody needs to break the ice.
Yes.
So, Dr. Kyrarini, you were talking about the difficulties. It's not actually difficulties. You said that different people from your control group had different ways of responding to how they liked working with your robot. So based on that, do you think that in the near future you will be working with, let's say, your robot being a stress reducer or a mood enhancer or something like that?
So that's our goal, actually. So what we are planning to do and what we're supposed to do based on the funding we got from NSF is that once the robot recognizes that the person is getting stressed or the person is distracted because they do something different, the robot should step up and help. So we're supposed to actually have a personalized response to whatever the person is feeling at that specific moment. So we do look more on like cognitive aspects. So when the person is actually cognitive fatigued and tired, because that's the moment that most likely we make more mistakes. So having the robot recognizing that and actually, first of all, informing us about it. And second of all, trying to take over some of the tasks that we are doing, that would actually be beneficial. We do plan to actually have user studies that we could verify if the people really like it or not.
Awesome. So is there anyone with any other question? If you don't have a microphone, please feel free to write it over the chat. The chat is open to everybody.
Hi, Professor. So I'm Mohammed Sadman, the Vice Chair of WIE. So I had a question. You mentioned in your slides that you would like to train your robots that have been trained on one particular task to like switch it to another task. So I wanted to know like transfer learning could be a solution to that problem where a robot that is trained on one task, we take the weights that is learned from that task and apply it to another task, or is there like some other updated technique for doing that?
No, I think transfer learning is the way to go for it. The problem is that transfer learning works pretty well if the task is kind of like similar, but not when you have completely different tasks. So for example, if I teach the robot how to pick an object and place an object, I cannot take that skill and transfer it to the robot being able to open the door. So in that case, we do need actually to find ways that we can generalize more. So yes, transfer learning can help when we have similar scenarios, but not when the scenarios are completely different.
Oh, thank you, Professor.
You're welcome.
Anyone that wants to go next? Okay, I can open a more general discussion and I think our audience can also participate. So Maria has spent several years in Europe, in different countries in Europe, and then several years in different states in the States. So if you want to share your experience, like what may be the different aspects or challenges that you have faced in different parts of the world or in different levels of your academic career, like as an undergraduate, as a PhD student, as a postdoc, as a faculty, because we have young PhD students here in the audience that they look up for role models, and those experiences, I think, sharing the reality of the world out there, I think it's valuable for them.
Yeah, that's actually pretty interesting. So when I was in Greece, we only had 3 female professors, if I'm not mistaken, out of 50 professors that we had to take classes. So already it was like, I couldn't really see that's why probably I could never think that I could be a professor. So when you see that, all of your professors are male, you get kind of like, oh, okay, this is like a place that's like, only for men. Then also within our group, I think we were maybe 20% female and like 80% were like guys. So it was really like always I was feeling like, we are kind of like the outliers. Then when I moved to Germany, I think it was like, yeah, my professor was a male professor. The postdoc was female. And then I started realizing, okay, so there is some difference here. And then there were several PhD students that they were female, but again, I think we were like 30% female and 70% male. I mean, my professor in Germany had, I think, the highest rate in the university of female PhD students graduating, which was really impressive. And for electrical engineering. When I went to Texas, I was actually working for a female professor. And that's how when I started saying, I could actually probably be a professor. Again, I was a postdoc and most of the students, the PhD students were again male. When I came here actually at Santa Clara University, our chair is a female, the dean is female, and also half of my department, we have female professors.
That's
So,
impressive.
Yes. And that was, I really took that into account when I was choosing where to go, because I think that was the only school that I saw so good statistics in faculty and electrical and computer engineering with so many females. And I realized, okay, this is actually a good change. I have to say that this quarter, I'm teaching one of the introductory courses. I have 33 students. I think I have 11 or 12 that they are female.
That's also impressive.
That's very impressive. So I'm super happy about it because that's the first quarter I have so many female students in an introductory course.
Yeah.
So I think that slowly things are changing. And if we see more role models in positions that we never thought before, hopefully we can have more females joining engineering, hopefully.
Yeah, you are for sure a very healthy role model for your students. So I think that they are very lucky of having you. Okay, thank you so much. Any other comments or questions that our audience wants to chime in? Okay, if there are no other comments, or I don't know if you are quite shy today, I think that we can summarize and end this session here. I would like to thank you, Maria, very much for taking the time to give the talk and also share your experience. I think that, people with a long trip ending up in academia, I think that they are examples for our young PhD students that, there may be challenges, difficulties down the road, but, there is a happy end at the end. So thank you very much for today, and I will pass it to Aisa so she can summarize and end this session.
Thank you so much, Dr. Siropolo, and thank you so much, Dr. Kyrarini, for joining us today. So
Thank you so much for inviting me. Sorry for interrupting.
That's okay. So our affinity group, we have the vision that we want to promote women engineers and scientists among the girls so that they are not scared, or they are more encouraged to pursue their career in STEM, because me being a woman, I know that it is very difficult. And your example for today is really, really inspiring. Seeing that you only had like 3 women faculty in your university and all these. So I really think that you have a very inspiring story. And I hope that everyone that joined today will learn a lot from you. Also, your assistive robots for people with impairments. Throughout your talk, I was so engaged because it is really something that I think that people should be working on. So, if you would like to add,
social impact
yes,
is important.
Yes, social impact is important. that is also one thing that Dr. Siripola has taught me so much. So if would you like to add something before we end today's talk, Dr. Kyrarini?
I would just like to thank you. It was really great. Thank you so much for inviting me. It's really nice to see again Dr. Chiropoulou after, I think, a year that we didn't see each other.
Yeah.
Okay, then. Thank you so much, everybody, for joining. I hope everybody has enjoyed. The recording of this video will be uploaded to YouTube so that if anyone wants to watch it or if you want to share it with your friends and your family, then you can definitely check it out in our YouTube channel. Thank you so much, everyone. Have a very good evening. I will be ending the meeting right now.